Yes. 67, the initial number. Okay. I'll see who is there, who is not there. Okay, welcome back after long gap due to some my personal reasons and same time college works, college farm development works and inspection works. I was coming back. I'm coming back now, and I think most of you feeling headache. Why this guy again came coming? Anyhow, today we are going to discuss about principles and practices of precision agriculture. Today we are only discussing principles and the differentiation of variability aspects. Okay, is it clear for everyone? Voice, audio, video?
Yes, sir, it is clear, sir.
Yeah. For any concept, there is some basic principles is required. Otherwise, there is not a concept. Here also in our precision agriculture, precision farming, there is a few principles on which this concept, this precision farming is works. Based on that, basic principle of your precision farming, precision agriculture is understanding the variability both in time and space. What is that? Understanding the variability both in time and space. Okay, we have to understand the variability. What is the variability? Variation. Where we have to understand within the field there may be a variation. We have to understand that which type of variation is there, which type of variability is there, and what extent, what is the quantum of variability. These two things we have to find. In we then on which dimensions? In space dimensions, same time in time dimension. So the basic, very basic fundamental principle of your precision farming is understanding the variability in both time and space dimensions. Yes. What we have to do for that? No field around the world is identical, and variation may be seen in any of the soil or crop or weather factor. There is no field in the world is identical, uniform. There is a variation, and this variation may be seen in any of the forms. Maybe this is soil variation in among the soil properties, variation in crop growth, variation in weather factors, whatever it may be. There is a variations. These variations we have to understand before going to implement your precision farming. To carry out your precision farming activities, to use your precision farming tools. Variation is found in all agricultural fields and may vary in soil fertility, moisture content, soil texture, topography, pest population, pathogens, intensity, weed density, etc. etc. Yeah. Okay. What I am telling, variation is there. Variation is found in all agricultural fields. Which type of variation? That particular field may vary with soil fertility levels from one corner to one corner after every 3 meters, after every 4 meters. Maybe soil fertility levels may vary due to pH variation, due to some other reasons, due to calcium carbonate content, due to sodicity. Then moisture content, the moisture holding capacity and available moisture also vary within the field. How it will vary? How the moisture content vary? Yes, Mr. ID number 2, Achut. Achut, please, please tell me. I don't understand. I didn't understand how it will vary. Moisture content in the field, how it will vary? Yes.
Moisture content.
Yes, it is very because of maybe your soil profile, your soil texture and texture may be different. Your texture maybe some in the one area in that field to a 1 hectare field, maybe some granular type of structure and some clay loam, and somewhere that is something changed, more sand content may be increased, loam content may be decreased, or clay content may be decreased. Then it will be vary moisture holding capacity and moisture availability. Maybe sometimes the weed density is more, then more uptake, then less moisture availability. Then soil texture may vary, topography, undulation. Okay, then your entire field is not uniform. Your elevation not uniform your slope. No, it's not possible. There may be a possibility of variation. Then pest population within the field also there is a possibility of, in some area there is a more pest above the ETL, some area below the ETL. But what we are doing, we are spraying the your insecticide commonly uniformly to entire field. We are it's a cost effective. It's more we are also spraying in unnecessary unuseful area, less pest area. So more cost of production is increasing. Then more using more chemical, it's entering into the atmosphere. Okay, biosphere, again the pollution problem, labor issues. Then what is other pathogen intensity? Same like pest. Then weed density also vary place to place within the field. In some place more number of weeds than another corner, another bit, another grid you can call. So these are the variations may be found in the field. So the basic principle is, here you have to remember, even if you take 1 hectare of field, there is no uniformity, there is a variation. Then multiple years of yield data from the same field usually exhibit both spatial and temporal variability. How you will know there is a variation? If you take 1 hectare field, you divide into different blocks. This is one A, B, C, D, and it just take the data of yield data of continuous of 5 years or 10 years, and you just record and give the all the inputs, apply the same throughout all years. You give you carry out all the management practices uniformly, even though there is a variation of yield within the block A and block B, due to the variation, soil fertility variation, soil nutrient availability variation, moisture variation, all those things you can observe easily. Okay, multiple years of yield data from same field usually exhibit both spatial and temporal. We can observe place to place variation and time to time variation. This year to next year variation also we can observe. Then after, it is very difficult to explain those factors including soil condition, weather factors and management practices. We can't find that which due to which particular cause this variation. That is difficult. So what we have to do? Hence, the art of precision farming, art of precision agriculture lies in basic principle of understanding the variability both in time and space. What is the variability causing this difference? That is we have to identify. That is the art of the your precision farming. Then just look on this diagram, this picture here. Recommendation of N rates, they are recommended different level of N rates for particular field. This is they are given as some, this area they are giving some rate, this area they are, maybe this green area may be sufficient. Okay, these are the yield levels, and they are recommended for red, this red area, whatever the red zones, these are the your zones. What zones? Your fertility zones are fertility. This is a fertility map. Here we are observing this red area means the more deficient in nitrogen. That's why we have to apply more nitrogen, 40 kg nitrogen per hectare. Coming to green area, sorry, this is less deficient and 40 kg. Green area, more deficient. Okay, we have to apply more nitrogen. Like that, we have to identify the variability. Then we have to differentiate, and further we have to manage based on the variability. We have to manage the field based on the variability. That not only nitrogen, not only phosphorus, not only nutrient, it may be moisture, whatever the management practices we have to manage. To manage this, to carry out this precision farming technique, first we have to understand what is the variability and what extent what is and what is how to up to what quantity, that is variable. Okay, this is the within the field there is this much of variable variations may be possible. Here you can observe this is okay, soil level, soil fertility, nitrogen deficiency. Here you observe the growth variation in case of growth. Within the same field there is a, we planted some crop. Okay, we providing all the inputs uniformly. Even though there is a, you can observe the growth of this plant crop is different. This is high, very high growth, vigorous growth, medium growth, very low growth, due to variability. Okay, here time, temporal variation, and same time here you can see here in above whatever the chart given here in 2 years. This is the means temporal variability. Here in 2012 it is high, in 13 also it is high, but the difference is there. Okay. So then that is first principle to understanding the basics. Then second principle of precision farming is collection and analysis of the data, spatial and temporal variant data information. Collection and analysis, we have to collect the data. Okay, I told you, you just understand the variability. Then how you have to understand? You have to understand the variability, you have to collect the data, collect the information, then we have to analyze the information. How you have to collect and how you have to analyze? You have to collect the data and you have to analyze the data, collect the information and analyze the information of crop soil environment or variation in crop and soil environment by using the relevant information technology, IT technology like remote sensing, GPS, yield monitors, okay, and all other techniques I told you earlier. Okay, remote sensing. How it is useful? Remote sensing is useful to collect the data, collect the information. Okay, then GPS. How it is useful? To locate that remote sensing is collecting the data and GPS is locating the data is pertain to particular longitude or particular latitude or particular point. The data is pertain to that particular SBR college farm, SBR college farm, Nakalagandi farm at the block number 5 at longitude this one and latitude this one. Then yield monitors, yield the variation in yield maps. It also gives you the information that there is some this type of variation or variable, there is a variability, field maps. This is the second principle. First principle is understanding the variability. Second principles, further you have to, you understood there is a variability, you know that, but how you have to uh, how to come to conclude that variability means you have to collect the data, you have to collect the data and analyze the data, and with the help of these tools, and you have to conclude there is a this type of variability and this much variation is there. Okay, in precision farming variability in time also plays an important role. Yes, variability, spatial variability, place to place variability is important. Same time temporal variation from growing stage, from sowing to harvesting, there are different stages, there is a variability. From year to year there is a variable temporal variability within the crop, within the field also is there. Okay, during certain period of crop growth there is a high availability of nitrogen up to reproductive stage, then after it may be decreased due to so many factors. That variability also we have to identify. The recommended nutrients of current season may not be required during the next season. Yes, you just you just observe in rice wheat cropping system, we suggest phosphorus for any one of the crop. Whatever the phosphorus we applied for paddy is sufficient for wheat. Sometimes whatever the recommended nutrients in kharif, it's not required for your Rabi. Hence, for taking various management decisions before going to apply some particular fertilizer or particular management practices, we have to consider all this. One should evaluate in-season nutrient deficiencies, by appropriate technologies. What are the appropriate technologies? Again, coming to your remote sensing, then your SPAD chlorophyll meter, your green shaker, hand holding devices. That is also the same principle of NDRI. I'm sorry, that's why this one. Your naturalized vegetative difference index. Okay, but same time you have to identify that variation. It may be through remote sensing, through it in your NDVI value, and you have to go further. In within during the crop growth period, we have there is a differences. There is a variability of availability of nutrients, availability of moisture. We have to find this before going to take any management decision to apply any nutrient, to apply any irrigation. What are with the help of different technologies, different tools. That are tools is your remote sensing tool, your handheld devices is there, leaf color chart is there, then your green shaker is there. Based on the NDVI concept, that all are works. What is the NDVI? Yes. What is the NDVI? ID number 2. Yes. Please. See is there or not? Otherwise, pass on next.
Yes, sir.
Then what is the NDVI? NDVI. Narendra Modi, not Narendra Modi. Okay. Natural ND, difference of vegetative index, natural difference of NDVI, yes, like that. Just confirm once. Okay. So that what is the principle of NDVI? Natural difference of vegetative index. That is works on chlorophyll content. Your chlorophyll content in leaves. That your maybe your green shaker or maybe your hyperspectral or multispectral images that sensors calculate or observe the what is the difference of chlorophyll levels in that leaves. If more chlorophyll, more greeniness means chlorophyll again interrelated with nitrogen levels. If more nitrogen sufficiently available, then it is more green. Means nitrogen is sufficient. Like that. NDVI calculates the chlorophyll content. There is a formula of NDVI. We will discuss in previous next classes, upcoming classes. That is the principle. With that whatever your remote sensing or hyperspectral, multispectral, then your green shaker, your leaf color chart, your chlorophyll meter. Okay, SPAD chlorophyll. This is all are works on NDVI, natural difference vegetative index. Then the recommendation of nutrients of current season may be or may not be required during next season. Hence, for taking various management decisions, before taking various management decisions, one should evaluate. You have to evaluate. You have to assess in season. In season means during that season, nutrient deficiency by appropriate technologies. All these technologies. Hence, second principle of precision farming is timely collection and analysis of the spatial and temporal variant information of crop, soil, and environment by using the relevant information technologies like remote sensing, GPS, yield monitors, green shakers. Okay, so many sensor technologies there now. The collected information is to be analyzed. Okay, we are collected. We are just not you are collected and just dumped. It's not solve your purpose. Collected information you have to analyze. Analyzed by following appropriate analytical procedures for getting support to the decision making. Then okay, for collection of the data, these all are the technologies available. For analyzing the data, what is the technology? Your GIS technology, your algorithm technology, your sensor technology, then whatever your this one neural network technology or your machine learning, your artificial intelligence technology, or your what is the internet of things, cloud computing. These all are the technologies available to is available for analyze the data, collected data. Okay, especially your algorithms and neutral this one neural network and all those things. And your that these are the part of your GPS, sorry, GIS, geographical information system. Okay, collected data, analyzed data, you got some conclusion from that. That one you have to give inputs to decision management system. There is another system is decision management system, DSS. This is one of software. So computer based software. You have to give this all. This is the 1 hectare area. If you have to feed that map, that GPS enabled map into that DSS system, you have to give this is the different zones. This is a high deficient zone, low deficient zone, and this one. Then that is give you output how much where you have to apply or how much whatever. That is the procedure. Collection, analyzing, then implementing is the process of precision farming. Then the third principle underlying with the precision agriculture is managing the variability with the site-specific agronomic recommendations. Yes, you analyzed the data and you found that there is different variations in the particular area. This area is less nitrogen, that area is high nitrogen, this area is yield drained, that area is good drainage facilities there, that is very fertile, it's lower fertile. Then you have to, based on that variation, based on that problems, you have to follow the specific agronomic practices for that particular, to solve the particular problem. After truly analyzing the variability within the fields, each field is to be divided into proper management zones. You have to divide the entire field based on the variability into what zones? Proper management zones, such as high yield zone, low yield zone, high fertile zone, low fertile zone, medium fertile zone, acidic zone, basic zone, sodic zone, ill drained zone, and so on. Like that, you have to first you have to divide the field. Why? Because the uniformity not our concept. You are not applying any nutrient, any fertilizer, any management practice. We are not doing uniformly. Here the motto is you have to give based on the requirement, based on the problem, not blanketly. Your normal agriculture follows the blanket application, blanket management. Blindly we are applying uniformly into entire field. But in precision farming, based on the requirement, based on the need, based on the problem, based on the variation. So you understand the management, you understood the variability. The first you have to understand the variability, you understood. Then second principle, you have to collect the information or data and analyze the data. You analyzed and collected and analyzed, and you found some variation. Based on that, you divided the field into different zones. Then based on that, you are followed the management practices, agronomic practices. Here you observe in this different mappings, pictorials. GPS mapping, remote sensing and GPS mapping, and GIS. GPS, GIS and remote sensing. These all are the heart of your precision farming, heart. Okay, interrelated. What a GPS does? It indicates the variation at particular which point, variation at the what are the which particular point. What your remote sensing does? It collects the data, variation data, and it is GPS indicates. What GIS does? Analyze the to and gives you the whatever the our readable form or understandable form of output. Then remote sensing, collecting data from field. Here in remote sensing, there is a different sensors is there. RGB. What is the RGB? Not RGB. RGB. Red, green, blue. Okay. That is visible light. Hyperspectral. Hyperspectral, continuous spectral, without gap in spectral signature, continuous spectral measures, very sensitive and very precision. Then multispectrals, some selected spectrals, like your infrared, near infrared, then visible, like that. Then you are here, here this picture is what it is indicating. Just someone. ID number 4, 5, 6, 2, anyone. Just tell me why I kept this picture here, what it indicates. Yes. 1 to 10. If anybody not told, then I 1 to 10 is absent. Anybody just tell me what is this? Then 10 to 20. 1 to 10 all are absent. Are just see. Just look at that.
Remote sensing.
Huh? Potato joke tunada? Yield monitoring, yield mapping. Simply they are mapping the yield. This is manually they are yield mapping. They are monitoring the yield of yield mapping. What? Me nidra mapulu. Okay. This is a equipment that is variable on a part of the variable rate technology. It's this equipment harvester. This is a harvester enabled with GPS, then yield monitoring tools, yield monitor display, and all these things. This is a very sophisticated and very costly also. Yield monitoring equipment. It will gives you the if you are your paddy is on a 1 hectare paddy. If you harvested with the help of this harvester, command harvester, then it will give which particular meter square area given how much of yield. Then there is a based on this you can find out easily what is before this variable rate technology of precision farming, how we will monitor the yield. Anybody? Otherwise I will come back to one by one. Yes, ID number 25. యా ఇది రాకముందు ప్రిసిషన్ ఫార్మింగ్ లేకముందు మనము కూడా yield మానిటరింగ్ చేసేవాళ్ళం ఏ ఏరియాలో ఎంత వచ్చింది అని. వాట్ ఈస్ ద ప్రొసీజర్ ఫర్ దట్? వీఆర్ డూయింగ్ దట్ ఫర్ ఓకే ఐ విల్ టెల్ యూ ఫర్ this one insurance before this remote sensing and all to claim the to means to give the claims of this one crop insurance. We are following one technique. We are means Department of Agriculture or government or insurance company following one technique to found the variability or variation, temporal physical variation of your yield at that particular field or particular farmer level. What is that mechanism? ID number 25, ID number 29, ID number 50. ఏంది తెలుసా తెలియదా? నోరు లేవా? మూగమైనాయా? Then
సార్ క్వశ్చన్ ఒకసారి చెప్పండి.
to find out the variation in yield within the field, insurance companies or government of India or state governments or Department of Agriculture following one method to resolve the claims of your insurance, crop insurance. They are following one technique. What is that technique? Now we are telling this precision, what is this yield monitoring precision farming tools, variable rate technology tools. With this you can easily find out the variation within the field or within that this thing. But to claim, to give the claim of insurance, there is one mechanism generally government or Department of Agriculture and insurance company is following to find there is a yield. పోయిన సంవత్సరం వచ్చిన yield లేకపోతే the basic the baseline yield every year 50 quintals per hectare ఉండేది. ఈ సంవత్సరం నాకు లాస్ వచ్చింది. I got some loss due to some rainfall, some flood or due to some cyclone or due to some drought. I got some loss, so kindly give me my insurance. Okay, claim. I am claiming my insurance. Then that insurance company or government of India follows one procedure, standard procedure to resolve that. Means it's really there is a yield variation or not. To find out that they are following on technique. What is the technique? Yes. Yes, what is the technique? Nobody? Ignanika. ID number 57. Teja. Nobody? Have you heard about crop cutting experiment? Crop cutting experiment? Yes, ID number 28, 29.
విన్నాం సార్.
ఏమిన్నావు?
గ్రౌండ్ నెట్ కి ఇప్పుడు ఏమైనా పంటేస్తున్నా వాళ్ళు ఇన్సూరెన్స్ వాళ్ళు వస్తారు సార్. ఒక ఏరియాలో 2 మీటర్స్ తీసుకొని దాంట్లో అవన్నీ హార్వెస్ట్ కటింగ్ చేస్తారు సార్. వాళ్ళు ఇంత ఇంత వెయిట్ అని ఉంటాయి సార్ గింజలు ఆ గ్రౌండ్ నెట్ దానికంటే అనుకునే దానికంటే తక్కువ వచ్చింది అనుకో వాళ్ళకి ఇన్సూరెన్స్ క్లెయిమ్ అవుతుంది సార్.
ఎవరు చెప్పింది? ప్రేమేందర్ రెడ్డి. ప్రేమేంద్ర
సార్
అర్థమైందా? మళ్ళీ చెప్పా.
ఇప్పుడు గ్రౌండ్ నెట్ అట్లా ఏమన్నా పంట వేసినాం అనుకో సార్, ఇన్సూరెన్స్ గ్రౌండ్ నెట్ ఎట్లా అప్పుడు ఒక హార్వెస్టింగ్ టైంలో ఒక 2 వారాల ముందు ఇన్సూరెన్స్ కంపెనీ ఒక ఏజెంట్ వస్తారు సార్ దానికి ఇన్సూరెన్స్ క్లెయిమ్ కావడం కోసం. అతడు ఏం చేస్తాడంటే ఒక 2 మీటర్స్ ఏరియా తీసుకుంటారు సార్, అంటే 2 మీటర్స్ స్క్వేర్ తీసుకొని ఆ ఏరియాలో అన్ని కట్ చేస్తారు సార్, కటింగ్ చేస్తారు సార్. అంటే విత్తనాలు అవి గ్రౌండ్ నెట్ కింద తీసి పక్కన వేస్తారు సార్ తాట. దానంతా వెయిట్ చేస్తారు సార్, బరువు ఇస్తారు. ఆ బరువు మామూలుగా ఇంత వెయిట్ కంటే తక్కువ వస్తే ఇన్సూరెన్స్
బేసిక్ గా 50 కిలోలు రావాలా,
దానికంటే తక్కువ వచ్చిందంటే అప్పుడు ఇన్సూరెన్స్ ఇస్తారు సార్.
So he is eligible for insurance. If that is only 50 or above 50, then he is not eligible for insurance claim. This is crop cutting experiment. But what is problem with this? It's very laborsome, and this manpower is not sufficient to visit every farmer's field or every village to conduct crop cutting experiment. Same experiment also doing by Department of Agriculture, State Department of Agriculture. It's very problematic, and sometimes maybe that particular insurance agent or that department person maybe with taking some bribe from that farmer, he may sow low yield. To avoid all these things, now we are using remote sensing based crop cutting experiment or remote sensing based yield monitoring. And this concept we are now, this Narendra Modi included in Fasal Bima. Whatever they are a new crop insurance scheme, that is Fasal Bima. Students, I am telling you, just mug up your stencil before one night, so before one night or 2 nights in your exam, and getting 8.5 to 9.10 GP is not going to give you your bread and butter. Finally, if that type of your mentality, attitude is pushing you into again పుట్నాల దుకాణం. వచ్చాడబ్బా వీడు మళ్ళీ సొల్లు పెడుతున్నాడు. నేర్చుకోండి, కష్టపడండి, చదువు అంటే మీ డోంట్ ఇన్ narrow boundaries, exploit your learning process, exploit your thinking process. Just learn practically what happening in market, what happening society, what you are learning, and just what is their applicability in society. Not only vision farming, not only this remote sensing or crop cutting experiment, everything. You are studying even now endosulfan in your entomology is there in market. What is the upgradation is there? Books is there, not upgraded. You just learn, you just visit. Now you are in you are at home, you are enjoying mostly. Also you are boring with online classes also. Whenever you get time, you just visit your nearest fertilizer shop. You just ask what is the latest molecules of different insecticide, pesticides. Okay, no use. Okay. Okay, that all are monitoring, that all tools are to collection and analyze the data. Then with the help of that, I am dividing my entire field into different management zones. Okay, these are the different management zones, and I am applying different here for this field, this crop, this area, this meter square. I am applying 20 kg. This area I am applying 18 kg only. This is less deficient, high deficient. This is only for precision farming. Precision farming is nothing but site specific location specific farming. It indicates that particular area, within that particular field, there is a variation of requirement and variation of availability. So we have to queue based on their requirement. ఇద్దరు వచ్చారు మీ ఇంటికి, ఇద్దరికి అన్నం తినడానికి భోజనం చేయడానికి వచ్చారు. ఒకరికి ఎక్కువ ఆకలి అవుతుంది, వానికి ఎంత తింటాడో అంత భోజనం పెట్టాలా. ఇంకోటి కొంచెం తక్కువ ఆకలి అవుతున్నాడు, అంత ముందే మార్నింగ్ టిఫిన్ చేసి వచ్చాడు, వాడు కొంచెం తక్కువ పెట్టాలా. ఇద్దరికి ఈక్వల్గా పల్లెం నిండా పెట్టేస్తే ఏమైంది? వాడు సగం మానే వదిలేస్తాడు, వేస్ట్ అవుద్ది. లేదు ఇద్దరికి కొంచెం కొంచెం పెడితే రెండో వాడు సరిపోద్ది, మూడో వాడు తక్కువ ఆకలితో ఉంటాడు. వాడు పని తక్కువ, వాళ్ళు ఇద్దరు ఇంటికి పని చేయడానికి వచ్చారు సపోజ్ కన్స్ట్రక్షన్ వర్క్ కి. రెండో వాడు సరిగ్గా పని చేయలేదు, మొదటి వాడు సరిగ్గా పని చేయలేదు, ఎందుకంటే వాడు కడుపు అన్నం తినలే, ఎనర్జీ లేదా. దట్స్ ఆల్ సేమ్ ప్రిన్సిపల్, నథింగ్ యువర్ ఫిషన్ ఫార్మింగ్. ఏదో ఇక్కడ వీఆర్ టెలింగ్ ద డిఫరెంట్ ఏదో టర్మినాలజీ టర్మ్స్ ఇంగ్లీష్ చూసి డోంట్ బాదర్, డోంట్ పానిక్. Then according to the local circumstances of a given field, according to the local circumstances of a given field, many times I am telling you about your soil testing reports or fertilizer recommendation doses. Generally your university or your Department of Agriculture giving one this one 160 for cotton, entire Andhra Pradesh or entire Rayalaseema or entire Kadpa or entire Badvel. They are giving, how they are giving? They are collecting some samples of that mandal randomly. Based on that, they are arriving. Is it applicable for all fields? No, they are giving blanketly based on that. But now the time for precision agriculture we are taking. Within the field there is so many variations, so we are preparing within the field 100 grids or more than that grids based on requirement. That's the concept. According to the local circumstances, local in your field, not someone field in your Maidakuru or Maidkuru. Okay. Okay. You have to follow, you have to carry out your recommendation practices based on your local circumstances. Management decisions for seeding or nutrient management or plant protection measures, etc. are to be taken up. You have to taken up management decision based on your local circumstances, your field level circumstances. Those precision agriculture is based on the spatial and temporal knowledge of soils, crops, and environmental condition in the management decisions. Yes, is it? Precision agriculture is based on the spatial, space, location, and temporal time, different time. Knowledge of soils, spatial and temporal variation, knowledge of soils, variation of soil, their crop growth variation, yield variation, environmental condition variation. Based on that only we have to follow the management practices. That is nothing but precision farming. Based on the variation of your soil fertility levels or soil moisture levels or crop growth levels or environmental conditions or rainfall distribution or rainfall quantity, we have to follow the specific management practices, not blindly, not uniformly. That's all. The process and properties which have a considerable influence on crop growth and yield. The process and properties which have considerable influence on crop growth. If you follow, sorry, just a minute. Gayatri.
Good morning, sir.
Good morning, Amma. I am in class. Just
Sir,
call me.
1 minute, sir. Sir, domicile certificate and residence certificate.
Yeah, both are same. Domicile and residence are same, or nativity also same.
Okay, sir.
You called me on that day, yesterday or some day, and at that time I am talking with someone. I called back, but that time you are not available.
Okay, sir. Okay, sir. Thank
Okay. Anyhow, I call you after half an hour.
you. Okay, sir.
Okay, ma, all the best. And you have not told me which university allotted.
I will send you invitation, sir. MPUIT Udaipur.
Oi, congratulations, Udaipur. Okay,
And
Maharana Pratap.
document upgradation.
Okay, what is your before option?
That now, sorry, but one girl got that, so she is not getting.
Okay, but my option. Okay, you are both are Rajasthan, so you will try. Okay, anyhow I will call back. Okay. Anyhow, congratulations once again.
Thanks.
Okay, ma. Okay, come back. Sorry. Then the process and properties of this type of precision farming location specific management, which have considerable influence on crop growth. If you follow the location specific management based on variability conditions, spatial and temporal, that have influence on your crop growth and yield, definitely. Weak ga unnodiki, so one guy is very weak and thinny. If you given good quality healthy food, then the improvement will be automatically good. And those guys already in fatty, if you are again feeding, then that is excess to him, and that is further causes health disorders, and the productivity of that guy will be reduced. Then The farmer should have the availability to locate the patches where growth and yield variability occurs. What farmer has to do? Farmer should have the ability. Farmer ki ability undali. Which ability must have? He should have. He must locate the which within the he has only 1 hectare area. Within that 1 hectare area, which location, which part is growth is very slow, which part is very good, nice growth, which vigorous growth. He able to identify. He must able to should identify. Able to identify that patches of differential growth, that variability. For this purpose, yield maps are produced with the data from the yield monitors. Okay, 1 acre or 2 acres is not an issue to he can observe with his naked eyes, and he will follow the management practices. But more than that, 20 acres, I can't. Any farmer also can't. For that, we have to use all these tools, techniques. Based on that, we have to produce yield maps of last 10 years or last 30 years or last 5 years. Based on that yield variation, we have to follow the, based on the yield maps, differential rates, we have to apply. Differential management practices, we have to follow. Okay. Then there are extremely useful in these yield maps are extremely useful in providing a visual image to clearly show the variability. These colorful maps, maybe fertility maps, are you can assume that your yield maps clearly visible, must have clearly visible and clearly differentiate the variability. Based on this, you have to apply the differential management practices, follow the differential management practice. Okay. Hence, in identifying the presence for variability in crop growth, hyperspectral imagery or airborne digital photography is to be taken at periodical intervals. How we identify the variation, this variability? Yes, I told different tools now available, starting from your RGB up to some extent to your multispectral, hyperspectral imagery, your airborne digital photography, your drone based hyperspectral, multispectral. Okay, with the help of this all these sensor technologies, we have to take collect the data of different times, after every 15 days interval or every 20 days interval or every 1 month interval. Based on that data, we have to analyze and we have to interpret. Such type of technology tells the real cause of variation. Okay, how? Okay, we come to know that there is a variation, but which type of variation means we are taking the maps. Okay, the some plants are very vigorously growing and some plants is very poor growth. How we know that is moisture deficiency or nutrient deficiency or what is the deficiency? For that, you have to use your multispectral or hyperspectral or digital photography. These sensors have after that sensor data, after analyzing, we get separate indexes, the NDVI value, then moisture stress values. There is different indices is there. We will discuss in later class. Based on that indices, we will finalize. This is this type of shortage, this type of deficiency. Due to this problem only, this plant is growing very poor. The plant growth is very poor. Yes. Such type of technology tell us the reason or cause of the variation, that may be nutrient deficiency in soils and plant systems, or biotic stress or abiotic stress, disease patches and abiotic stresses such as moisture stress. All these things we can find out with the help of my hyperspectral, multispectral or airborne digital photograph. Then advantages from precision agriculture can be realized only if variation are known. When you get the advantage of this precision farming, yes, if you correctly found the reasons for variation and what is the variation, then only we can apply the proper management practices. Then only that problem or that stress will correct it, and it will give, you will get good yield. So you have to know the reasons, know the cause, know the variation. Without variations, either spatially or temporally, the question of application of precision farming will not arise. Yes. Okay. There is a one ideal farm, ideal field, 1 hectare or 2 hectares. There is no variation. There is already entire field with 0.1% slope, very uniform, very no slope, almost uniform. Then what is the meaning of using your laser based leveler? There is one leveler is laser based or means precision farming GPS based leveler. What is the use of that leveler? Already is level. So only where is the variation? Then only we have to apply the precision farming. Moreover, okay, there is a variation, okay, but that variation, this zone to that zone is 0.1 kg per hectare difference. 0.1 kg. This was small variation. This gives any additional advantage of following all these things? Nothing. It is more cost effective. The advantage is cost is more than triple or quadruple than your advantage. So you have to consider the variation, same time magnitude of variation, quantity of quantification also you have to see quantity of the variation. Quantity, that magnitude of the variation should be large enough to allow proper management decisions. Okay. For a given parameter, the variation must be exceeded the threshold limit such that for a given parameter, the variation must be exceeded the threshold limit such that improvement can be made over whole field management by site-specific management practices in crop production. What is that? For a given particular parameter, maybe you take the nitrogen deficiency again. The variation must be exceeded the threshold limit. There is a threshold, ETL. In case of your entomology, you will talk ETL. Above threshold level only you have to apply the particular insecticide. Here also you have to keep some ETL. Above that only, if you follow the your precision farming tools, techniques, even for to divide your management zones or your yield mapping zones only, that you keep on threshold level. If within that all 5 to 6 kgs, you keep under 1. Only 5.01 is one zone. It's not meaningful. Okay. Otherwise 10 to 30 kgs is the one. 30 to 40 is one, like that. Okay. Then advantages from precision agriculture can also realize the variation follows a particular pattern, and if the suitable technology is available for identifying and assessing the variation, you will get the fruits of this precision farming only when there is a variation follows some specific pattern. Uniform means specific variation also, there is a uniformity in variation, some specific pattern if required, otherwise the zigzag, it's a very difficult. The suitable technology also required to identify and assessing the variation. It is common to have a detailed measure of variation within a field. It is common to have a detailed measure of variation within a field with little understanding of the cause of the observed variability. Detailed measure of variation is required within a field with a little understanding of the cause of the observed variability. Then we have to, okay, there you find that variability is there, but what is the cause of variability also you have to observe. To sum up this, all this basic, these are now we are discussing 3 different principles and what is the different causes and different aspects about this. The basic principle of precision agriculture lies in underlying the variability in time and space. Then what is the basics? What is the basic 3 principles? Underlying the or understanding the variability in time and space, temporal and spatial, or assessing the variability and managing the variability with a site-specific agronomic recommendations. You have to understand, you have to assess, you have to collect the data, and you have to analyze the data, and you have to assess the data, and you have to find the variability. Then you have to manage that variability with specific agronomic recommendations, agronomic management practices with specific tools and techniques. These are the principles of your. This you can see here the different management zones, crop management zones. Okay, like this. This is a healthy area. stressed area. Okay, some different types, very medium stressed, highly stressed. Okay, here you can see. Okay, this is like this. We have to divide the entire field, different based on different. There are quantity of variability. Then we have to follow the different management practices. How we are with the base of the sensor technology, photography, whatever that remote sensing, we have to identify these differences. We have to divide the like this, and we have to apply the recommendation. We have to apply the nutrients, apply the pesticide, or apply whatever the recommended agronomic practice we have to follow based on the differentiation. Yes. Okay. Then. Now. Okay. I think your lunchtime, so that's why. Now, tell me what you understood. What any doubt? Any doubt about this class?
No doubt, sir.
No doubt.
No, sir.
Then shall I ask questions? Yes. Tell me.